Welcome to the final module of our OOP journey. We've learned the 4 pillars: encapsulation, inheritance, polymorphism, and abstraction. Now, it's time to solidify that knowledge by applying these concepts to a real-world use case, building a simple library management system. 1. Project overview. Our system will manage books. We need 2 main classes. First, the booked class, which holds individual book data, and second, the library class, which manages the collection of books and handles operations like adding, listing, and searching. 2. Applying the 4 OOP pillars. How will we use the 4 pillars? We will use encapsulation in the book class by making attributes like title and author protected or private, and providing getter and setter methods to manage access and control data validity. We will use inheritance by creating specialized subclasses of book, like ebook or audiobook, which inherit common properties from book but add their own specific attributes. We will use polymorphism by designing a method, maybe get_details, that behaves differently based on whether it is called on a regular book, an ebook, or an audiobook object. We will use abstraction to define a common interface for all types of books, ensuring they all implement necessary methods, regardless of their specific type. To summarize, this use case will be a powerful final exercise, showing you how to structure complex, object-oriented applications. We'll start immediately by designing the core data class. Join me as we create the book class. Our next lecture, 21.02, Create Book Class. See you there. Welcome back. Our first task in building the library management system is to define the core data structure, the book class. We will use this class to demonstrate encapsulation by making our attributes protected and controlling access to them using property decorators. 1. Defining the protected attributes. We start by initializing the core attributes, title, author, and ISBN. We are using the Python convention of a single underscore prefix, like underscore title, to mark them as protected. We also add underscore is underscore available to track the book status, defaulting to true. This is the data hiding part of encapsulation. 2. Implementing the getter for title. To provide read-only access to the protected underscore title, we define a method called title and decorate it with @property. This allows external code to access the title as if it were a regular attribute, but internally it calls this method. 3. Implementing the setter for author. For attributes we want to allow modification for, like author, we define a standard getter using @property and then a corresponding setter method using the @author.setter decorator. Crucially, the setter allows us to add validation logic, ensuring the new underscore author is not empty. This control is the core benefit of encapsulation. 4. Utility method. Finally, we add a simple utility method, get_details, to easily retrieve a formatted string of the book's information. Notice how we use the public properties self.title and self.author when available and directly access the protected underscore ISBN and underscore is underscore available from within the class. To summarize, we have a robust book class ready. Our next lecture, 21.03, Create Library Class. See you there. Welcome back. We've created the book class and ensured its data is encapsulated. Now we'll build the centerpiece of our system, the library class. This class will be responsible for managing a collection of book objects and providing the main functionalities of the system, such as adding and listing books. We will again use encapsulation to protect the book list. 1. Initializing the book collection. The library class starts with a constructor that takes a name. Crucially, we initialize a protected instance variable _book as an empty list. This list holds all our book objects. Marking it as protected enforces that external users should interact with the collection only through the public methods we define, not by directly manipulating the list. 2. Adding books to the collection. The add_book method is our controlled interface for modifying the _books collection. Here we can add validation, checking if the provided item is actually an instance of the book class. If validation passes, we safely append it to our protected list. This prevents rogue data from corrupting our system. 3. Listing the collection contents. The list_books method provides a clean, abstract way to view the contents. This method internally iterates over the protected _books list and uses the get_details method we defined in the book class. This is an example of strong cooperation between our encapsulated classes. 4. Method for borrowing. We define a placeholder method, borrow_book. The user only needs to know the interface. Pass the title and the system handles the complexity of searching, checking availability, and updating the book status. The implementation details are hidden, perfectly illustrating abstraction, which we maybe will implement later. To summarize, we now have two robust, encapsulated classes, book and library. Our next lecture 21.04, test. See you there. Welcome back. Before moving on to inheritance, we need to ensure our foundational classes, book and library, are working correctly. In this lecture, we will test the encapsulation we built into the book class and verify the core functionality of the library class. 1. Creating library and book objects. Let's start by creating an instance of our library called my_library and two instances of our book class. These objects are now ready to be managed by the system we built. 2. Testing encapsulation. We test the encapsulated access. When we print book1.title, the property getter is automatically called, giving us the value. When we update the author, the property setter is called, which runs our validation logic, successfully updating the protected _author attribute. If we attempted to set an empty string, the setter would raise an error, proving our data control works. 3. Testing library functionality. We add our valid book objects to the library. The add_book method runs successfully. More importantly, we test the encapsulation logic in add_book by attempting to add an integer. The method correctly detects that it's not a book object and rejects it, preventing corruption of the _books list. 4. Listing the final collection. Finally, we call my_library.list_books. This method accesses the protected list, iterates through the valid books, and calls each book's get_details method, presenting a clean output. Our foundational design, based on encapsulation, is now fully verified. To summarize, our core system is stable. Our next lecture 21.05, Inheritance and Polymorphism in Action. See you there. Welcome back for the final lecture of our library management use case. We've established a stable foundation using encapsulation. Now, we will introduce inheritance to create specialized book types and use polymorphism to treat them all uniformly within our system. 1. Defining the ebook subclass. We create the ebook class, which inherits from book. In its constructor, it accepts an extra attribute, file_format. We use super.double_init_, to initialize the inherited attributes, title, author, and ISBN. This is inheritance in action. Then we demonstrate polymorphism by overriding the get_details method. We call the parent's implementation using super.get_details and simply append the new, specialized detail. 2. Defining the audiobook subclass. We follow the same pattern for audiobook. It inherits common data from book, but adds duration_minutes. It also overrides get_details to include its specific duration information. The inheritance ensures code reuse, and the overriding ensures specialization. 3. Testing polymorphism in the library. We instantiate our specialized books. Now watch how the my_library.add_book method, which was designed only to accept book objects, accepts both the ebook and audiobook. This is possible because of inheritance. They are both considered types of book. 4. Polymorphic output. When we call my_library.list_book, the library iterates over its list. For each book, when it calls the get_details method, it automatically executes the correct, specialized version, whether that's the base book method, the ebook method, or the audiobook method. This is runtime polymorphism, allowing the generic library code to handle diverse, specialized objects seamlessly. To summarize, the library management system demonstrates the practical power of all 4 OOP pillars working together to build flexible, maintainable code. This brings us to the end of the OOP section. Next, we are going to a new section, Section 22, and our next lecture is 22.01. Introduction. See you there.